There's actually in the news pretty much on a monthly, if not weekly basis, examples of critical equipment being exposed on the internet and being breached.
Welcome everyone to the Industrial Security Podcast. My name is Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions, who's going to introduce the subject and guest of our show today. Andrew, how's it going?
I'm very well, thank you, Nate. Our guest today is Robin Berthier. He is the CEO and co-founder at Network Perception, and he's going to be talking to us about machine analysis of network zoning. So, basically analyzing our networks so we can understand attack paths.
Okay, then here's your interview with Robin.
Hello, Robin, and welcome to the podcast. Before we get started, can you tell our listeners a little bit about yourself and about the good work that you're doing at Network Perception?
Thanks, Andrew, for having me. So my name is Robin Berthier. I'm the CEO and co-founder of Network Perception. We're a cybersecurity software company. We help OT networks to get understood, visualized, and analyzed for risks. And my background is in computer science and cybersecurity. I grew up in France, moved to the United States in 2005 for grad school, and then moved from grad school to Chicago to launch Network Perception and support the critical infrastructure industry by developing solutions that helps practitioners in those OT and cyber physical system environments.
Thanks for that. And our topic today is analyzing networks, analyzing zoning. You were on the show 6 months ago, walking us through your network modeling tools, your capabilities back then. To remind our listeners, back then you were reading and analyzing config files and backups for firewalls and routers. In my recollection, this lets you visualize the network. It lets you, design a policy, express the policy to your tool, compare all of these configurations to the policy. The policy, this machine can be reachable by those networks, but not by anything else, and then report on deviations. Is the network configured the way we think it ought to be configured? And, you're back. So you're talking about today, what's new? Is there a new problem that you're solving?
Yeah, so two things are happening. One inside Network Perception and one outside. Let me start with the outside driving force first. So in the last 6 months, we've seen an uptake in terms of interest by organizations with OT networks to formally verify the segmentation of their environment. It's becoming more and more of a priority for them, and I think that's driven by both a more pressure from adversaries and making sure you have the right access policy in place to block attackers. To prevent a breach from spreading to the critical zones inside your network. And it's also driven by more stringent regulations. We've seen with NERC-CIP, we're seeing now with the TSA security directives, there's just more focus being put around the importance of extremely robust network segmentation, good hygiene for your firewalls, and having very precise rules to only allow traffic on a need-to-know basis. And then the second thing that's happening inside Network Perception is that we, I didn't mention in my background, but I really have two passions. One is cybersecurity. The other one is information visualization, and specifically how to present a large volume of data into concise reports that leads to efficient decision making. So over the past couple of quarters, we reflected on the data analytics that NPView provides, And we went back to the brainstorming and the whiteboard to really think how to best present that information, because sometimes you start importing firewall configuration files and you will have thousands or even tens of thousands of network paths being discovered by the modeling engine that tells you the exposure of your different critical assets. So how do we compress and present and summarize this information in a way that's helping you making better decision in terms of risk, in terms of the risk really to your network?
This is, of course, a very important subject that Robin is hitting on here. Network segmentation comes up in any domain of cybersecurity at some point, relatively frequently. In IT especially, I can think of a million examples where an attacker started off with one network resource and ended up moving their way through a network because it wasn't segmented enough. The classic example being the Target breach back in 2013 when a phishing email at a small HVAC provider in Pittsburgh led through Target's client portal, supplier portal rather. Attackers got into the network associated with the HVAC systems and ended up burrowing their way through the Target network through to their point of sale systems, and then stole a bunch of credit card information. The story goes on from there. So all that is to say, this is very important. You and I have talked about air gapping and unidirectional gateways and all of these relevant technologies before.
Absolutely. And, where to begin? It is important. This is why, the first volume that was published in the 62443 series, it's a 14-volume set of standards. The first volume was, half of it was about segmentation. It's that important. And on the OT side, to me, the classic example was the ransomware attack. Snake got into Honda a couple of years ago. I mean, there's been lots of ransomware attacks that had OT consequences, but that was sort of the highest profile one that had, enough detail published to be able to figure out vaguely what happened. And in my recollection, it was the bad guys got into the IT network through the IT to internet firewall and pivoted from the IT network into the OT network and, contaminated the production line with ransomware, operated the ransomware remotely, encrypted stuff, blah, blah, blah. And so, there were firewalls all the way along there. And, what people don't understand is, when I entered the industry naively, much more than a decade ago, I had sort of the same perception everybody else did. You take a little encryption, throw a few firewalls at it, some VPNs, and you're good, right? ? And, it was once I started digging into it, bluntly, I went to SANS training on firewalls and I was appalled. And a couple of years later, I put together my own presentation on 13 ways to break a firewall. What's the low-tech way to break a firewall? You shoulder surf as, the firewall admin enters the password and you enter it yourself later on and add a rule that says allow all and it's all over. What's the high-tech way to break a firewall? You find a 0-day, a bug that no one else has found in the firewall. You write code to exploit the bug. You sneak your way through the firewall in a way that there is no defense against because there's no patch for the bug. There's no attack signature for the attack. It's brand new. What's the modern way to break through a firewall? Well, we've talked about it countless times. You get into the IT network. You trick various ways into people and technology into getting domain credentials, and now you give yourself permission to log in to systems through the firewall and work your will upon the target system. Here's a pop quiz. What is the most widely known, sort of the instinctive, the knee-jerk reaction? How do you break through a firewall? What's the most widely known way through a firewall?
Is it like they do in the movies where you type a bunch of zeros and ones until you get a notification that pops up and says access granted and your screen scrolls really fast?
No. Good one.
I have no idea.
Okay, it's the most widely known is you don't attack the firewall itself. You know every firewall. People imagine that firewalls protect industrial systems from cyber attacks. They give you access to industrial data, but they protect the industrial systems. In fact, that's not what firewalls do. What firewalls do is they give you access to some industrial systems and hopefully block you from others so that you can ask those industrial systems for data. If you ask for data politely, well, you get data back. If you ask for data impolitely by, let's say, guessing the admin password instead of going in as your mere user password, now you're attacking the OT system through the firewall. This is the way that everyone knows. Of course, you can attack through a firewall. The firewall gives you access to a handful of industrial systems and lets you send messages to those systems, and some of those messages can be attacks. And so, this is back to the point here with Robin. If you can send messages to the OT systems through the firewalls, you can attack them. You can pivot attacks into those systems. And so, in my understanding, this is, the question he's asking of, I have, in a refinery, I don't know, dozens and dozens of subnetworks and dozens of firewalls and, configuration for all of those firewalls. The most complex would be the IT/OT firewall, but, there's other configurations everywhere else. And the question becomes, where can I pivot? How many steps do I have to go through? How many systems do I have to compromise before I get from where I am on the internet or in the IT network or whatnot to a target that has really high value? How do you do that? And this is the kind of analysis that his tools are doing. So that makes sense. Pressure from various kinds of regulators, pressure from the threat environment, people caring more about how their networks are configured and, which parts of it are more or less easily reachable. But if I recall, that was kind of what you were focused on the last time as well. What's changed that, you needed to build something new?
So yeah, good question. So based on that reflection we had to improve presenting large volume of data into concise reports that are leading to efficient decision making, we started to work on a new capability for the platform that we call a zone segmentation matrix, and that feature takes your entire set of connectivity paths in the environment that you're modeling and presenting it according to a matrix of zone-to-zone path. So in one single screen, you can see, like a bird's eye, you can see which network access would present a risk for your environment. So for instance, that matrix will reveal if someone from the corporate network would have direct access to your SCADA environment, and if so, on which port. Before, you had to go one by one into a subnet, an asset, and then look at the path in and out of that asset. Now we're surfacing in that matrix right away those different results, and so that gives you a faster way to identify overly permissive rules, overly permissive segmentation or gaps in terms of your network segmentation.
All right. So the ability to, visualize at a glance and see where problems are in larger network configurations, that sounds good in theory. In practice, you mentioned standards, you mentioned drivers. Can you connect the theory, the capability to the practice? How would you use this for INSM? Can you remind us what is NERC INSM?
I mean, as a general theme, network visibility has been a key challenge for OT infrastructure, where you have geographically dispersed facilities and then some very legacy equipment. And so getting good visibility over those networks is difficult. So FERC asked a year ago NERC to start drafting a standard around internal network security monitoring, INSM. And the concept there would be that even if you implement good cyber hygiene, even if you have good proactive defense initiatives in place, if an adversary is able to breach your environment, you should have, as part of your defense in depth, you should have capabilities to monitor suspicious network traffic and alert you and detect if an attack is going on. So NERC is in the process, the drafting team are in the process of crafting a revision to the standard to include a requirement around putting sensors inside those critical networks in order to capture the traffic and detect intrusions. It's still much work in progress. Actually, 2 days ago was the end of the voting period for that first version. I don't think that version was accepted, so it's going to go back to the drafting team for some changes. And then we're going to know in the next few months in the final version with a actual enforcement date in the next couple of years. But this ties into that big theme of network visibility. And for us at Network Perception, it's really important that we support the industry gaining a much more precise understanding of those OT networks. And we see our solution as extremely complementary to the network traffic monitoring product that are on the market. We call this the two sides of network visibility. So on one side, you have actual network traffic monitoring. And then on the other side, you have what we do, which is network modeling. So when you monitor network traffic, you can see in real time what's happening. And you can answer questions such as, is there something suspicious occurring now in my network? When you do modeling, you can answer a different question, which is what can connect to what. We covered this in the last episode of the podcast. Now, with the INSM, the push for the INSM regulation, we're helping in two ways. Number one, we can help organizations to better plan for the deployment of their sensors, because with NPView, you can very quickly generate a reference architectural diagram for your environment, just in the config file of your firewalls, routers, and switches. And so once you have that diagram, the decision of where to put sensors in order to capture the correct critical traffic is easier, specifically with that zone segmentation metric that I referred to earlier, where you have that bird's eye view and you see what are the critical connectivity paths, which zones should be instrumented with those sensors. And then the second value is to be able to build context around the event that you're going to trigger through that network traffic monitoring sensor. So, for example, you have a suspicious network connection that connects to a critical equipment. You want to know first, how critical the equipment is, in which what's the source zone of that traffic, what's the destination zone, and then if that equipment gets compromised, where could an attacker go? Like, what are the other paths that could be taken for this attack to propagate inside your environment? And that's the contextual environment, the contextual information that we can provide for users.
Imagine that you work in a power plant. You're responsible for a half dozen massive boilers. If a cyber attack makes one of these boilers overpressurize and explode, that explosion will most likely kill you. Which protection from that cyber attack would you prefer? Would you like a mechanical relief valve, one that steam pressure forces open when the pressure gets too high so the steam is released harmlessly? Or would you rather have a longer password on the PLC controlling the boilers? The engineering profession has powerful tools to address physical risk from all causes, including cyber risks. But where is the relief valve in the ISO standard or the Industrial 62443 standard? These engineering tools do not exist in cybersecurity standards. Andrew Ginter's latest book, Engineering Grade OT Security, A Manager's Guide, looks at this topic. You can request your free copy at waterfall-security.com/engineering-grade-OT-security.
So, Andrew, it seems to me that we have spoken with many guests before about modeling attack paths, about modeling networks and such. What is the exact distinction in what Robin's talking about here?
Where to begin? Robin, I think, actually later in the episode says this, so I'm going to repeat what he says in a moment, but I think I recall him saying, drawing a distinction between intrusion detection, looking at network packets, and the kind of analysis that his tools do. Intrusion detection looks at what connections are happening. And if you see an unusual connection, one that you haven't seen before, you might raise an alarm saying, someone should look at this. I've never seen this before. So it looks at what's happening. The analysis tool that Robin has doesn't look at what's happening. He looks at what's possible. He looks at the firewall configurations and says, well, this device here could connect to that device there. The firewall allows it, whether or not it's currently happening. IDS is what's currently happening, and his tool talks about what could happen to you.
I guess I'm kind of surprised that's actually never been covered before in all of our previous discussions.
I could be wrong. I don't recall it has been covered, but we're at 120 episodes. My my memory fails sometimes. I do remember that something like this we talked about with Terry Inglesby at Amanaza. His company does the attack tree analysis, where he says, well, how could you get from a source, the internet, a source of an attack, or a malicious insider sitting at that workstation or whatever. How could you get from the source of an attack to a high value target? Well, first you'd have to break into this machine. Then you'd have to get through that firewall. Then you'd have to, and each step he assigns a weight indicating how difficult it is to do that, how capable the adversary has to be. And he puts together, all of the possibilities into a ridiculous number, sometimes literally over 1 billion possible attack paths, weighs them all and says, here's the bit you should be worried about. But in my recollection, and I could be wrong, his tool looked at things sort of a little bit generally, whereas what Robin's tool is doing, what Network Perception is doing, is looking at the config files for the firewalls and saying, here's everything that's possible. Not sort of generally, well, an attack could pivot through the firewall. He would say, well, these machines here can talk to those machines there. That's all the firewall allows. And so he's doing that sort of detailed analysis that I'm not aware that other people are doing. IDS is, what is happening. You're talking about context. Are you supplying that context in a sense in real time? Are you taking the alarms in and analyzing the IP addresses and somehow augmenting them?
So step by step we are. So we started to develop integration with the IDS vendors to be able to first enrich the topology map that we generate with the asset and equipment that has been detected as communicating on the network, because so far when we create a map, we are inferring the presence of endpoints based on references that we extract from the configurations of firewalls, routers, and switches. But we don't know for sure that those IP addresses, there's an equipment behind it. But if you start integrating with your network scanners, your asset inventory solution, your IDS providers, then we can turn those inference into actual endpoint, communicating and being present on the network, which is enriching your map. So that part is you have prototype available today. The next phase in that roadmap is to be able to also visualize the network traffic directly inside the NPView map. So that's something on which we're actively working. Right now, you can leverage NPView to contextualize, but that's not yet, automated through integration.
So that makes sense. Another thing that you said that intrigued me, you said figure out where the adversary can go if an intrusion detection system, an IDS, is alarming about a particular asset that appears to have been compromised and is now sending out probes and attacks to other, or suspicious traffic to other assets. This is pivoting. This is using a compromised machine. I heard you say that you could figure out what assets were at risk by a pivoting attack, given that a certain asset might have been taken over. Well, in the worst case, if an adversary is taking advantage of, known vulnerabilities, exploiting vulnerabilities, and a lot of control systems they're not fully patched. It's hard to patch these systems because of reliability concerns, because of safety concerns sometimes. In the worst case, you can pivot to, arguably everything on the local network and everything through firewalls that anything on the local network can reach. It does a little good if you take over one asset to take your entire zoned network map and turn the whole thing red and say, this is where they can go eventually. I'm guessing you've got something finer grained. Can you talk about, what you actually show people? Is it one or two steps ahead? Is it something else? What, other than the whole thing lighting up?
Yeah, that's a great question. So currently we're looking 4 steps ahead. So what we do is to leverage our understanding of your network segmentation. So based on your access policy, firewalls, routers, and switches, what are the pivots from one subnet to another subnet? Now, within a single local area network, to your point, it's game over, right? If you have one equipment compromised, and then that switch is not segmenting the network into VLANs, so you have pretty much everything can talk to everything else in that one subnet, then there's not much you can do. Where we're refining the analysis there is to be able to ingest also the reports from vulnerability scanners. So if you scan that environment, either actively scanning or passively monitoring, to extract which IP addresses is hosting application where you have a vulnerability, then we're planning to refine that analysis to show you exactly which CDE ID could be exploited on which port and services. But that really leads to the discussion around actually the importance of reducing the size of your segment. The whole macro segmentation movement, right? So instead of having a giant local area network with dozens of IP addresses, segmenting with VLANs or segmenting with actual firewall access control to be able to group by level of criticality and function equipment, so that if something is compromised, then you contain within a very small zone that breach.
So Nate, I don't know if it was completely clear, but what I just heard Robin say there was that this tool is helping us answer the question, how should we design our networks? How should we segment our networks? Look at you look at the internet, you look at the threats out there. Nation states are out there stirring the pot. Ransomware is out there. Some of the ransomware is backed by nation states. They've got the capabilities of nation states. Some of the ransomware is rich enough to buy their own nation state tools. They're rich enough to build their own nation state grade tools. So what's coming at us across the internet can be really nasty. And the bad part about these ransomware with nation state tools is that, unlike nation states, they're not just going to go after important targets. They're going to go after everybody with money. So if that grade of ransomware is coming after us, we got to ask the question, have we designed our networks in such a way as to defend them properly? So we look at our networks, and generally you've got two kinds of networks. You've got networks where the worst case compromise, if it occurs, is unacceptable. Rail switching systems, safety systems, and there's other networks where, well, if we get compromised, we kind of want to recover quickly, and we want our insurance companies to pay us out. But, it's a big deal, but it's not the end of the world. So in both cases, in both kinds of networks, we've got to figure out how exposed we are. If a bad guy from the internet wants to get in, how many steps do they have to go through? How many machines do they have to compromise and then pivot, use the compromised machine to reach through the next layer of firewall to compromise another machine? And what Robin's saying is that they're starting to integrate this tool, not just with the network diagrams to count the steps, but to look at the vulnerabilities in each of these targets and ask the question, how hard is it to carry out the next pivot? So, for example, if we have a really important system buried deep in our networks, and it turns out that we've designed the network, we've broken it not just into one big network, you're in. You know, Robin's saying, let's talk about finer grained segmentation, micro segmentation. If you break it into small networks and you've got to get from one small network into another one, let's say 3 or 4 hops in, and 2 of those hops have to pass through a machine that has 0 known vulnerabilities in it. Well, suddenly, the bad guys, if they want to get in, they've got to conjure up 2 0 days to punch through that kind of segmentation. That's expensive. And so, you know, it's not just how many hops that are being counted here, but it sounds like what we can start doing with this kind of system that Robin's putting together is getting insights into really how thoroughly protected or not our networks are. So that all sounds good. You know, I'm going to ask you in a moment for sort of examples and experience, but before I get to that, let me ask you about availability. This new capability, you know, I can't ask you for examples if it hasn't been released yet, or, you know, at least be available in beta. What's the status of this new development here?
Yes, so we are actively working with a few of our development partners on finalizing that release, and we're actually getting super close to releasing that to the market. So we're planning to have a launch of the latest version of NPView that includes that zone segmentation matrix at the S4 conference early March.
Okay, so then let me ask you the hard question about experience. You know, do you have beta customers? Do you have sites where you've been trying this out? You know, who've been working with you? How's it working? What are these people learning? What kind of feedback are you getting? You know, how's it going? Especially this whole pivoting concept sounds interesting. Have you got any examples of that?
Yeah, so our development partner, we are working closely with them to deploy that solution and inform them with what we call a stepping stone map, and that's what you referred earlier with the pivoting. And so what's interesting is that while we don't have example of actual network breach yet to illustrate the value of it, what we observed is just the initial value of enabling stakeholders from different teams and different backgrounds to understand finally like how the network environment is configured and what segmentation means and how things are protected. With the visual map and this lighting up the pivoting points, you put risk in context, and whether you are from compliance or cybersecurity or networking, whether you are a technical person or you are in the leadership, the picture helps everyone to have the same language to discuss about those concepts, which can be pretty complex with the size and sophistication of networks today. So the feature and the capability and the visualization of it has been received extremely well by our initial beta testers.
Okay, so let me ask you a what if. I mean, if I have a complex network and I've got high value assets buried deep in that network somewhere, protective relays or safety instrumented systems, or I don't know, leak detection systems, what do I know? You've got high value assets, and the pivoting path that I worry about is from a command and control center on the internet. Can I ask you, is it possible to take your tool and say, I'm worried about an attack from the internet? What's the shortest, the easiest path to get from the internet into these high value assets? And, is that possible? And, do people start seeing things that their eyes open and go, oh, shoot, I forgot about that? Is that doable with your technology?
Yes. So, and actually it's pretty interesting. Like every time we run that analysis for the first time, there are insights. I can't remember like a single example where someone saw the result of that stepping stone map and didn't tell us, oh, I didn't know that this was possible, or I didn't know that this access was, was doable in that environment. But so the way we do it, and often, you start importing some config files into the platform. They may not cover all your network path all the way to the internet, because you start with your critical environment, with your critical zone, like an ESP in the case of NERC. What we do is that when we parse the config files, we extract the routing table and specifically the default routes. And so we know that internet traffic or external traffic would come from a specific gateway. We put that gateway in the map. And then we have actually default template routers that you can also import in addition to your actual equipment in order to close the gaps between the environment you're mapping with the network that's connecting to the external world. And that allows to bridge and connect the different islands that you could see in a network map. And then we launch the stepping stone map from that external gateway, and you're going to see in 1, 2, 3, or 4 hops which nodes could be used as pivot for an adversary, starting from the external zone to go all the way to your critical equipment. Right now, this analysis is agnostic of your vulnerabilities, but we're working to be able to filter it down, to prune that set of capabilities, set of possible paths that we identified into, to your point, the shortest or easiest path based on vulnerability information, like which hosts have an outdated application or something that could be exploited, and matching a port or service that's available based on your firewall rules, and like really connecting the dots and combining those two data sets into an insight for you to know like which path is the riskiest in your network.
So, what you're saying here, it actually reminds me of, an experience in my past. I was at Industrial Defender. I was working with Jonathan Pillay, a very capable penetration tester. We were not doing a pen test. The business had been contracted with a customer to look at some network diagrams and, some systems, do a risk assessment, basically. And we did not have any kind of technology like this. And so I remember Jonathan sat down with, 17 3-foot by 5-foot as-built network diagrams, big, massive things full of, wiring diagrams. And he's paging through these things one after another. And he looks up and he says, you realize there's a path from the internet into your, deepest control system here without ever passing through a firewall, just routers. What do you mean? Well, on this network diagram, it starts here from the internet, and then you go to this machine and that machine through here, and then you take this thing over here that, is kind of off in the corner, takes you over to this page, bang, 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 you're in. And the reaction was, give me that, and, snatch the network diagrams back, kick us out, go and fix the problem, and, bring us back in a couple of months. Is this the kind of thing that you're looking at? Is this the kind of experience you're trying to prevent?
Precisely, and it's interesting because I can't find in my memory like a single example of a user who hasn't had this type of insight after deploying our solution. There's always a weakness or some misconfiguration or overly permissive rule that someone forgot inside their configuration that allows this type of of path, maybe not always from the internet, but for sure from an untrusted zone to a trusted zone. So the key there is to do that, with the power of technology, right? Because for, the expertise and experience that John is bringing your example, we want to be able to bring that capability without the risk of human error to the mass, and to be able to have all our stakeholders being able to identify those risky paths. But yeah, it's fascinating. Like we start, importing config files, the map is getting generated. And then, in those firewalls we have, in the routers, we extract the default gateway. So we know we can infer where is the external access point into your environment. We launch a stepping stone analysis from that access point, and, just a few seconds later, you see the nodes in your map lighting up, and, you're going to see your critical zone with everything lit up a specific color that says, this is protected, this is mitigated by access control. And then for sure, there's always like one or two nodes in bright red that tells you there's a direct access from an external IP address all the way to that critical equipment deep inside your environment that you have no idea about. And, the causes they vary, but often it's, someone added a temporary firewall rule like 6 months ago, and it was supposed to stay for a couple of days, but they forgot to remove it. We thought that this rule was actually preventing external traffic from getting in, but we had a misconfiguration. The rule never got attached to an interface, so the rule was useless. Just a line in your config that the file wasn't taken into account. We had examples of just object groups not being correctly defined. You have rules that are referencing source and destination services using groups, and then it's pretty complex as a human to keep track of that, right? You have to use lookup tables and make sure that you know what value is in which group, which set of IP addresses, which set of ports and services. And so often we see, an old IP or something forgotten that gives more access than they expect.
So the examples that Robin gave there were misconfigured firewalls. And, I just wanted to jump in sort of with a couple of examples of misconfigured firewalls of my own. I used to do a demo at like trade shows, how to break through firewalls, just an awareness thing, a threat awareness thing. One of the scenarios was just misconfiguring the firewall. And, we're not talking about home, small office firewalls here. We're talking about enterprise grade firewalls. And these firewalls have operating systems and user interfaces that are designed for scale. They're designed for big systems. They're designed to deal with complexity. And so, if you want to put a rule in there that says Andrew's laptop is allowed to connect to, the Pi server through the firewall, well, you can't it's not one rule. First, you have to define who Andrew is. And then you have to define what Andrew's laptop is. And then you have to define what the Pi server is. And then you put a rule together, not with Andrew's laptop's IP address and the Pi server IP address and allow. You put together, you have to define service numbers, the port numbers as well. You put a rule together that says roughly in English, Andrew's laptop is allowed to connect to the, Aviva Pi client server port on the Pi server in the DMZ network. You use almost exactly those words. Okay, there's no IP addresses anywhere. There's no usernames. It's all symbols, and they do this so that these thousands of complicated firewalls are comprehensible. But what it means, and my demo, what it means is that you can look at that firewall rule and say, "There's nothing wrong with this firewall rule. Andrew's laptop is allowed to connect to blah blah blah. The rule is right. Yet I'm letting the entire IT network connect to the Pi server. There's something wrong with this rule." And you can stare at the rule till the cows come home and you won't find it because there's nothing wrong with the rule. What's wrong is with the definition of the IP address of Andrew's laptop. You've buggered up the definition and you've included the entire IT network in the definition. You got to look in a different place. You got to look at the definition of each of the symbols. And, I forget the details, but there was another thing where, instead of saying, I'd messed up the definition of the DMZ network, and now you can connect to anything you want. If you basically these systems are complicated, and it really is easy to mess them up in ways that just aren't evident when you look at the definition and you try and understand what it's doing. So that's all fascinating. Have you got anything else for us? I mean, you seem to be a fountain of examples here. Where else, can we get insights from using technology like this?
There's actually in the news pretty much on a monthly, if not weekly basis, examples of critical equipment being exposed on the internet and being breached, right? The latest that I have in mind is the water and wastewater treatment facility in Aliquippa, Pennsylvania, that got compromised just a few months ago. And the issue came from a PLC with a human machine interface, an HMI, where there's a port on those equipment. Actually, in this case, TCP port 256 that was directly exposed to the internet. And then to make it worse, the password on that machine, that piece of equipment, was a default password from the manufacturer that hasn't been changed. So that got compromised pretty quickly. And this is the type of finding where if you have network modeling, you can very quickly, you import your firewalls, you import your list of equipment from your asset inventory, and you can see, okay, what's exposed and what's not exposed. So another example is last year, May 11, when you had a coordinated attack against 16 Danish energy companies, where an attacker exploited a vulnerability inside a firewall to be able to craft arbitrary command and run arbitrary command on those firewalls. So those network equipment were exposed to the outside, but then the network segmentation for the rest of the environment wasn't strong enough to contain those attacks. So the attackers on port 500 UDP protocol of those Zixel devices were able to get compromised and then pivot to our earlier discussion to get the critical equipment inside those 16 facilities. And so that's the type of insight you want to have prior to an attack, because the next zero day that is going to get published, you want to have the confidence that your segmentation and the zoning that you put in place with access policy is strong enough to contain any potential 0 day into a vendor of network equipment to a single zone and not propagating to the rest of your critical environment.
That all makes sense. We're coming up on the end of the episode. I want to say thank you so much for joining us. Before we let you go, can you sum up for our listeners what should we take away from the changing needs and the changing capabilities in the world of network segmentation?
Well, thanks, Andrew, again for having me. And sure. So really, the key point I wanted to make is that verification of network segmentation is becoming more and more of a priority, and it's not a one-time thing, right? Because the networks of today's networks are just growing in size and complexity and becoming more and more dynamic, even inside traditionally more static environments such as OT environments. So it's a cyber hygiene best practice to frequently make sure that the configuration of the equipment enforcing your segmentation, so the firewalls, routers, and switches, is correct, and they don't have overly permissive rules or gaps that could open up access to your critical equipment. So to that end, we are about to release the most capable version of our product in PVU that includes that new zone segmentation metrics to give you a bird's eye view of your exposure for your environment, really helping faster insight and decision making in terms of network risks. And I invite folks to check us out at network-perception.com for more information about how we can help them.
Andrew, that just about concludes your interview with Robin Berthier. Do you have any final thoughts that you would like to leave with our listeners?
I mean, reflecting back on the episode here, we're talking about network segmentation. This, in a sense, is the oldest trick in the book. It's the oldest tool in the trade. It's the first thing that was documented in the first volume of 62443 back when industrial cybersecurity wasn't industrial cybersecurity. It was SCADA security. It was, even the terminology's changed. And, firewalls have been around forever, yet, this is a new development in the field. I mean, when was the last sort of big new development in the field? It was deep packet inspection over a decade ago is my recollection. But here's a way to analyze networks. Here's a way to add context to alerts when there's potential intrusions in progress. We've been talking to some vendors of asset risk tools and asset inventory tools that they're working with the intrusion detection vendors, the alarming vendors, to say, look, this asset is at risk from this attack that's coming in here because they have information about the asset. Here's an extra step. The next step is, okay, given that this asset is at risk of potentially being compromised, if it were compromised, here's all of the other assets that would be at risk because this one's at risk. The field continues to develop. It surprises me that something as old as the idea of network segmentation, there's new inventions happening in the field. So, it's an interesting development.
Well, thank you to Robin for sharing that development with us. And Andrew, as always, thank you for speaking with me.
It's always a pleasure. Thank you, Nate.
This has been the Industrial Security Podcast from Waterfall. Thanks to everybody out there listening.